All right, 3 sets of examples left. All right, so this is just like the one we just did, except for these are somewhat nicer because they're actually, again, 2 perfect squares. So we will break this down into 2 sets of factors. Square root of 3x plus 2 squared is just 3x plus 2. So 3x plus 2 go in both of those, and then square root of 9 is just 3, so that's going to be 3 and 3. One's positive, one's negative, and then you can actually simplify the 2 and the 3 here and the 2 and the negative 3 here, so you just get 3x plus 5 times 3x minus 1. All right? Okay, same thing here, or similar thing here. Take the square root of this, and these reduce. Take the square root of these, and those reduce. So we get x plus 2, and then on the end we get x plus, excuse me, not plus, but minus 1, and x minus 1. One's positive, and one's negative. And now here's something that's important to note, is that this whole thing over here is negative, so we really need to put parentheses around this and then distribute that negative through to both of these. Okay? So over here we got x plus x is 2x, and then we have 2 minus 1, which is 1. Okay? And then over on this side, let's do this, just do this one step at a time. So we got x plus 2, and that's minus x plus 1, because again we distribute that negative through to both. So this ends up being 2x plus 1. X minus x is 0, and then 2 plus 1 gives us 3. So it's just 2x plus 1 times 3. And the better way to write that is just 3 times 2x plus 1. All right? So that's how you do those. All right. Next example, factorize 8x squared plus 24x plus 18. And this is from page 250, number 24. Okay? First thing to note here is that all of these are divisible by 2. So I'm going to factor a 2 out of all of these. And oftentimes a common mistake I see on this is that lots of people will try to factor an x out too. That would work for this term and this term, but this term here doesn't have an x, so you can't get an x out of that. So we can just take the 2 out. So we got 2 times 4x squared plus 12x plus 9. Okay? So with this one here, what we're going to try to do is just try to break this down as best we can. Okay? Now, this is a perfect square. The first term is a perfect square, and the last term is a perfect square. So then there's another nice little formula that we can use for that. Okay? And that says if you have it is x squared plus 2 times x times a plus a squared, then you will get x plus a squared. Okay, and this is in a formula from the previous page on 249. Okay, so what we can do on this, if you'll notice, we have again a perfect square and a perfect square. So let's do this. 2 times, and then the square root of 4x squared is 2x. Square root of 9 is 3. Okay, and this should be just simply 2x plus 3 quantity squared by using our formula here. Okay, now again, some of you are saying, whoa, wait a minute, how'd that work? Let me show you really quick here. So you've got, if you do 2x plus 3 times 2x plus 3, 3 times 3 is 9, 3 times 2x is 6x, 0 to hold in place. 2x times 3 is 6x. 2x times 2x is 4x squared. Add those up and you get 4x squared plus 12x plus 9, and that's what we started with there. Okay? That one's definitely a little bit more on the tricky side because you have to somewhat know what these formulas are talking about. But basically you want to, there's lots of nice little shortcuts once you find perfect square, first term and last term. Okay? All right, one last set of examples to go over, and that's to factorize 2x squared minus 2x minus 12. Okay, and this is from page 251. All right, so if you look here, this is kind of nice because all three of these are divisible by 2. So you can factor 2 out, and when we simplify that, we have just x squared minus x minus 6. Okay? And then once you have this here, since the leading coefficient out here is 1, you can just do the backwards attack at this for factoring, which means, to do a refresher on that here, this is 6. I say, what are the factors of 6? 1 times 6 or 2 times 3. What are the factors of 6? Since this is a negative, I say that have a difference of 1 because there's one x in here. Okay, so the factors that have a difference of 1 would be 2 and 3. So I'm going to put x and x, 2 and 3, and you could put the 3 here and the 2 there, it doesn't matter. And then I always know that this sign here goes with the larger of the two factors, so that's minus over here. And then I know that this here, since this is a negative, I know that I have to multiply a positive times a negative. So when I look at that, I say, okay, that means the signs have to be different because it's negative. So since this is negative, this has to be positive, and there's our factors. Okay, so that was a lot of factoring, but you should be able to say now that you can factor various polynomials. All right. If you have any questions, please feel free to ask. Thanks.